All right. Good morning, everybody. My name is Matias Madou, and today I would like to talk a little bit about budgeting, and if you have an application security budget, how you can best spend that, and what kind of buckets you have available to you, and what gives you the best return of investment. So my name is Matias. I started my career at Ghent University. I pursued a PhD in application security. It was more around code obfuscation, and essentially I started to realize that it's not really a good idea to hide stuff in code, right? You can apply obfuscation, but still the vulnerabilities are in there, right? So I was doing static analysis, and with my PhD, I moved to the US. I joined a company called Fortify that was very small at the time. I was the second researcher in there. We were trying to find the SQL injections, the cross-site scriptings in code. And over the course of 7 years, I realized that I think we were really good at finding problems in code. I also saw that the organizations that were using Fortify, they were actually piling up the bugs. You know, they were finding good stuff, the SQL injections, the cross-site scriptings, really, really good stuff, but also piling up the bugs because nobody knew how to fix these problems. You know, it is one thing to find problems, it's another thing to fix problems. And at the same time, they kept on introducing new problems in code. So with that realization, I said, hey, maybe we should start from the beginning. You know, how is it possible that people keep on introducing problems in code? How is it possible that nobody knows how to fix code? So with that knowledge, I started a company called Sensei Security, where the idea was to guide developers in writing secure code. And I found some really good guys, partners in crime, from Secure Code Warrior. They were doing the exact same thing. They wanted to tackle the problem like, hey, how can we educate developers? How can we tell him how to write secure code? But at the same time, how can we provide him with tools and solutions on a day-to-day basis that they can write secure code? So we merged the two organizations, and we are Secure Code Warrior, we help developers write secure code. Essentially, that's what it says. We want to make sure everything is running code, right? Everything is running code. So instead of building fences around it, we think that developers are your first line of defense. You really have to educate them. You have to give them everything, the power, the means to write secure code. So today I would like to talk a little bit about application security. And I thought initially I would skip this introduction because everybody knows about that. But there's one interesting stuff that I couldn't get rid of, and I really wanted to talk about it. So people say, well, if you write problems in code, it's going to lead to catastrophic failures and you can lose money. Can you lose money? Of course you can lose money. Look at the Ariane 5 rocket. They tried to cram a 46-bit number into a 16-bit area. That didn't work. They blanked out the error handling for performance reason, and it blew up. 7 billion was gone. 10 years of research was gone. So can it cost money? Absolutely. That's an example. Next step, and this is an interesting one, and Sony, they say, well, it can lead to brand damage. Yes, it can lead to brand damage. If you think about it, they got hacked through a SQL injection, but that's one thing. But they stored all their passwords in clear text in an Excel file. That's pretty bad, right? But then I got the question in my last talk, and I said, you know, but the stock didn't go down. You know, it went down a little bit, but now it's up again. And I started like, that is true. It's not related to money over here, you know. They have some brand damage, and at the same time, I'm still talking about that. So you would say they still feel it, but even bad publicity is still publicity. So now I'm no longer sure if it was a bad thing or a good thing for Sony, because I'm actually still talking about that. So I think it's only bad for the people that were in that position that stored the passwords in the Excel files. You know, it's bad for these people. But other than that, you know, I don't know. C-level people get fired. I think Target is a good example. I cannot remember his name, but it is DeRodes. He was the CIO, and he got a lot of knowledge in the security world. So he was really well educated. He knew his stuff. They got hacked. So yeah, he had to go. So these days, C-level people sometimes have to step down because of breaches. So AppSec, what's in the name? In the old days, this is the Ariane 5 problem where they blanked out the error coding or the error handling for that particular problem, so the rocket blew up. This is ages ago, right? But this is brand new, right? SQL injection. This is what that's what we face on a day-to-day basis, right? This is really the new stuff, SQL injection. Well, actually, it is quite interesting. I got this frame. It's an XKE from about SQL injection, and it's a real frame. I brought it with me when I was doing the MOOC interview with Philippe. It's a real frame, and I got that frame, and it's an interesting one, so I brought that to our office. But the really interesting part about that was the back of the frame. At the back of the frame, I received this frame from Jacob, who was my manager at Fortify in 2008. Okay, so this goes back to 2008. This is 10 years old, and at that point, it was not even rocket science, right? At that point, we were already working on the problem for years. So SQL injection is not the new type of stuff, you know. It's something that is very, very old, and yeah, go out there, go onto the wiki from SQL injection, and you will find a long list of companies that get still hacked through SQL injection. I think they gave up after 2015. They no longer add new entries in there of companies that got hacked through SQL injection because there's just too many. So what is the root cause of this problem? I think we're in an organization. So actually, who is an application security person over here? All right, who's the developer? Oh, good mix. That's going to be a fight, right? Normally you do not come along very well, and you're in one room. That's already good. So what normally application security people, you know about problems in code. I've never seen an empty bug tracking system. Maybe you guys have one, but I've never seen one. So you're aware of problems in your code. And what you do is you ask your developer, hey, can you fix the code? And the way you ask it, it differs from organization to organization. To make it politically correct. The developer, he doesn't really have a lot of good tools to help him, right? And we ask him to fix it. And normally the application security people, it's very interesting that you guys are here because normally you're way understaffed. Sorry. So first of all, you're going to ask the developer to ask to fix the problems in code. Well, first of all, yeah, the application security people, you're understaffed. According to BSIM, you are 2 people per 100 developers, so which means that you have to guide 50 developers at once. Pretty hard, I would say. At the same time, there's a ton of overhead. For every problem that you find, you have to find a solution. You have to file it in the bug tracking system. You have to split it up in a meeting as a developer. You have to take out the issue. You have to find a problem to the solution. You have to implement. You have to test it. You have to go through QA. You have to go through staging. You have to put it in production. So for the slightest problem that you have in your code, it takes a long, long time to fix that. So it costs a lot of money. So what I see quite often is, well, you do the OWASP top 10, or you try to do the OWASP top 10, you get rid of that, but everything beneath that, you know, is a no-go. That's no time for that. At the same time, people keep on introducing problems in code over and over again. So they keep on developing. There's never a time in a company where you say, well, we're going to stop today. We're going to first fix all our problems, and then we're going to start, you know, from that moment on. No, that doesn't happen. You keep on introducing problems in code on a day-to-day basis. So there's stuff that comes back. Why is that? It's actually very hard for developers. I'm not sure if you know, but static analysis solutions can find 700 different categories of problems. So you're aware of the OWASP top 10, and SQL injection is one, and cross-site scripting is a second one. There are 698 other categories of problems that static analysis solution can find. So it's really hard for developers to not introduce problems. And then there are the things that are unfound. There's still this notion of false negatives, things that you do not find in your code. So this is a never-ending story. And why is this a never-ending story? I think if you compare that with flying a plane, it's never the case where somebody says, well, I actually want to fly a plane today, and you go to the airport and they give you a plane and they say, sure, fly off. But essentially, that's what we do with developers, right? They come out of university, we give them a computer, we give them a GitHub access, and we say, go off, write some code. You see that happening, right? That happens on a day-to-day basis. So I think that's the starting point of the problem. You should educate these people first on how to write secure code, and then over time, you should give them a machine and make sure that they write secure code, right? So where do mistakes happen? We all have our stuff. We have Agile, we have Waterfall, and in that you can actually implement various things. You know, you can do threat modeling. I saw that good book at the Torian booth from Microsoft. That's a really good book. You can do threat modeling. You can do static analysis. You can do whatever. You know, and you can take whatever methodology. I don't care. This is not how developers look at this stuff. This is how developers look at the stuff. Developers look at it from a very practical way. They look at themselves, they are a developer, and they write code. They push it in a repository, it gets built, it gets deployed, and it goes to production. That's how a developer looks at code, not the previous thing. They don't look at the waterfall thingy, no. So where do they have, where can developers really help in terms of security? The first two things, it's themselves, the developer that writes code, okay? And once they push it into the bug track, into the repository, at that point, they think that they're going to sprinkle some security magic fairy dust over the code and everything is going to be secure, right? And we all respect each other in IT, right? So we have a lot of respect. So that's why I was asking developers versus security. I think we have a lot of respect for each other. It's not the case, right? If you as an AppSec person has to go to a developer and you're going to ask him to fix something in code, they're always going to say, no, you don't want to do that. You first have to really prove that there's an exploit vector that's going to work, and that's going to break. And even then, after a while, they still will not believe you. The best thing you can get from a developer is, meh, yeah, maybe. So where developers versus security, what can they do, what can they not do? Developers have total control over themselves and how they write code. Security does not have any control over the developer itself or how he writes code. Once it's checked in, the developer has no control whatsoever, but the security person can still pick that up, inspect that, and find problems in there, or potential problems in there. All right, so there are tools to help you out, okay? So you have a developer that can get training, he can write code, that's in this IDE. He pushes into the repository, you can use a static analysis solution. When you build and deploy and test, you can use interactive application security. When it goes to production, you can do dynamic application security testing. And when it goes in production, you can use a RASP solution or some self-defense in there. Okay, and each of them has their pros and their cons. Okay. So for example, a training, well, let's go to static analysis. What's static analysis? You look at code without executing the code. The good stuff about static analysis is you can find a lot of problems from a theoretical perspective. You get a lot of problems, and then the bad thing is, of course, that people will complain, well, there's false positives, there's stuff that it finds, and it's not a real problem in code. So it's good and bad. So it finds a lot of different stuff. It's going to give you good coverage over your code. At the same time, it finds false positives. And it cannot really do well with dynamic frameworks because you can only scan the code that is there. If it's dynamically built somewhere, well, it's very hard to scan that code. Interactive application security. What's interactive application security? It's essentially some monitoring solution that sits with the QA people, and it's going to give them some feedback on potential problems that they can further explore. Okay, DAST. More or less penetration testing solutions that gonna treat your application as some sort of a black box where it's gonna send random attack vectors, not random attack vectors because that's fuzzing, but it's gonna send well-crafted attack vectors and it's gonna inspect what's coming back from that solution and is gonna decide, yes, it's a problem or it's not a problem. And the RASP, Runtime Application Security Protection, is really some agent that you install in your servers, and it's going to monitor what's going on, and if it sees a problem or if it sees an attack, it's going to try to block that on the fly. So where do we spend money? If you look at these training, IDE, help, SAST, IAST, DAST, and RASP, where do we spend money? For some organizations, it looks like this. They spend a lot on SAST, they spend a lot on DAST. Other organizations spend more on training and SAST. The problem is nobody knows. So what I would like to do in the next couple slides, I would like to go through a couple things and figure out where people really spend the money. So first things first, what type of company would this be? And don't say my company, please, because otherwise we have another problem. But what type of company, what kind of stage are they? What does management think about security? Sorry? Or a startup, yes. Was not the answer that I was hoping for, but it always comes up. Any other takers? What kind of company? If it's a well-mature company? Yes, actually that's right. Actually, it's the all is good company, or the company that is not hacked. Management is like, well, we don't see the need for security because nothing happens, everything works, everybody's happy, right? Yet, what kind of type of company is this? Well, there's a huge pile of money, you know. I'm not sure. Well, I don't have that pile of money, but yeah. Well, this is actually Equifax today, I think. You know, this is the oh shit company. We got hacked. We have to do something. You know, we really have to do something. And what they tend to do then is they take a bunch of money and they say, "Whoa, what did they find? Is it a SQL injection problem? Whoa, we really have to find the SQL injection problems. Can we find some white hat hackers and can we install a program and find more of this stuff?" You know, they want to find more of the same stuff, making sure it does not happen anymore. Okay, and essentially over time it evolves, that company. Okay, so I started with the company that has no notion of security, then they get hacked, they get a notion of security, or something triggers it. There's always something that triggers it. And then over time, it spreads out. So I think this is kind of a view of where a lot of organizations are today. Why is that? Because they need training for their PCI compliance sticker. There's really good salespeople in static analysis that they can sell you anything. Gartner says you really have to put some money into RASP right now. Oh, I'm sorry. And Gartner says you really have to put some money into RASP, and you still have your bunch of money in penetration testing. I think a lot of organizations are in that particular situation right now. It's the reality. So where do we spend? And then I went back into BSIM, because BSIM is essentially building security and maturity model. It's based on what actual people do on a day-to-day basis. So they collect data and they figure out what people are doing. So I do not have access to that data, but I do have, well, everybody has access to the report that they produce. And if you look into that report, I found it quite interesting to see that for some of these things, you have entire practices, like you have a training practice, you have a code review practice, you have a security testing practice, you have a penetration testing practice. And then for RASP, I couldn't really figure out where that really fit in the BSIM kind of vertical, meaning if you look for RASP, it's not even found within the BSIM. So it's not there yet. So people do not spend a lot of money on that yet. Maybe they will, I don't know. But the reality is right now it's not the case. And even if you drill a level deeper into these practices, you can find activities in all of the levels. So they split it up in 3 levels. Where they have easy things to do, and then people do quite often things, and then really rocket science things. And even within there, you have all these 3 levels covered, for example, for training, but also for static analysis. You have all the 3 levels covered for dynamic application security. And if you look at IaaS, that's again a little bit minimal. You know, you find include security testing and QA automation. So based on that, based on what I see in BSIM, I would say people spend on training, on SAST and IDE help, and a little bit less on IST, a lot on DAST, and very minimal on RASP. This is the state of where we are right now in application security and where people spend their money. Okay. But you know, I can say this is not progress, right? I'm not making any progress. I'm not telling you what the best ROI, the best way to get some good ROI out of your application security budget. Okay, it only validates that yes, we need to spend money. So now I would like to take a step back, and I would like to look at what we really do in application security. And what we really do in application security is on the right-hand side we have the SQL injections, the OWASP top 10s, really the vulnerabilities, okay? And on the right-hand side, and if you take companies that get hacked through SQL injection, they say, well, it's in DAST, we found it in DAST, and maybe we should bring that closer to a developer. Maybe we should make sure that that we can find that particular problem very, very close to development. So this whole notion of shift left, where you try to figure out what the problem is as close as possible to the developer. Right? So you start with finding the SQL injections through penetration testing. The next thing is say, well, maybe we should find all theoretical SQL injections. So you go through a static analysis solution that finds all theoretical SQL injections. And then you really want to train the developers, making sure they know about SQL injections so they do not introduce it. So you go from right to left. But there's also this notion that going from left to right, where you really can say, well, let's introduce coding guidelines. And I found it really hard to find good coding. There are coding guidelines, there are good coding guidelines, don't get me wrong, but there's much more information about vulnerabilities and attacks and cheat sheets and all that kind of stuff than there is around OWASP secure coding guidelines, the Android secure coding guidelines. There's not a whole lot of stuff in that area, right? While I think it's very interesting, because What we do in our industry right now in application security is, let's say we have a query over here with 4 concatenations, parameter 1. By the way, I think this is the only code slide. So for developers, I'm sorry, this is the only code slide. You have 4 parameters, parameter 4, 1, 2, 3, and 4. Let's say your penetration testers come back and they say, you know what? Parameter 1, parameter 2, they are vulnerable to SQL injection. Well, you know, the company is on fire because it has to be fixed right now. We cannot be hacked through SQL injection. And they're going to instantly ask the developers to fix the SQL injection, and they will fix that one. If your static analysis solution comes back and they say, well, you know, parameter 3, maybe if the stars align in this way, then it's going to be vulnerable to SQL injection. At that point, over here it comes, you know, you can start your fight between your application security people, your developers, and your QA to really figure out if it's a problem or not, right? Because the developers will not say, no, we're not going to fix it. You have to prove it first. And the security guys, yeah, you have to fix it. So the QA comes back and they really have to find an attack vector to exploit that stuff, and everybody is mad at each other, right? Knowing the answer to the problem is simply irrelevant. Fix it, and it's not going to be a problem. Just fix it. Okay, but that's not the way we work right now. And if none of our solutions point out that parameter 4 is a problem today, we're not going to fix it. We're not going to do anything. The code is working. Leave it as such, right? While tools are incomplete, first of all, so you do not know if parameter 4 is really a vulnerability or not. At the same time, if another developer comes on board tomorrow, some guy out of university that had never heard about SQL injection, and he takes the code and he copy and pastes it into another location, it may also be a vulnerability, right? Or it may become a vulnerability, all right? Because the context is different. This is how we treat application security today. This is what we do on a day-to-day basis. We try to find a problem, and we're going to fix the problem one by one. Okay? So there's a very big distinction between finding the vulnerability and following coding guidelines. If you find the vulnerability and you run or you let people in and they do a pen test, or your static analysis solution is not pointing out anything, which is hardly seen. But let's say your static analysis solution doesn't show you anything. What does that tell you about the code? You don't know. You do not know. You know for sure if it's showing red stuff, if it's showing critical vulnerabilities, you know for sure you're in deep trouble. But if it doesn't show you anything, you don't know. The only thing you can say is that tool didn't find anything, or these hackers didn't find anything. But you do not know if your code is secure or not. At the same time, if you follow coding guidelines, and you say, for example, use parameterized queries, always, everywhere, okay? If you do that, you can eradicate SQL injection. Because if you do that on a consistent basis, always, everywhere, you can eradicate a category of vulnerabilities. And you can start to measure it. You can start to measure if you follow coding guidelines, if developers say, nah, this is an exception, I'm not going to do that, or if you bluntly violate a coding guideline. And at that point, you can actually compare applications against each other. You can say, well, this piece of code was developed by group A, and they did so good, versus another piece of code developed by group B, and they constantly introduced or did not follow coding guidelines. So you can get a sense of how well that application was developed, and you can essentially put a risk score on there, what the problems may be in the future of putting an app like that in production. And you can map that back onto the previous graph, right? You can say, well, on the right-hand side, you really want to find the vulnerability. You can do everything you can with developers and you can tell them what to do, but eventually you still need that mechanism. So these need to be in balance. I'm not saying that you need to prefer one over the other, because we know how creative developers are. If you tell them follow these coding guidelines, they're going to follow the coding guidelines in a very creative way, right? So you still need that stuff. You still need these mechanisms that find the problems in code. So the whole idea over here is how about making sure that you, again, optimize your budget and optimize your solutions? Because if you can eradicate 80% of the problems here, then the 20% these solutions are going to find are really the hard to find problems, the stuff that you really want these tools to find. You know, you bought a complex SaaS solution, for example, not to find the easy SQL injections. That's right. Or you're not hiring very experienced penetration or white hat hackers to find a very simple configuration problem, right? So you want to really make sure that you use the expertise and the knowledge that these tools and people have to the most. So where do we have to spend it? And I'll circle back to my initial title of the talk, which was 3.6 million is the average cost of a breach. And this is actual data. This is actual data from Jim Routh. In my previous calculation, I used the numbers from Aspect Security. They also put out some numbers. However, there's no source of where that really comes from. These are actual numbers. These are numbers from Jim Routh from Aetna. He went through that exercise. He calculated how much it costs for his organization to fix something in requirements, in design, in code, in test, and in maintenance. Okay, and my feeling is, in general, I think there's a general consensus that the earlier you fix stuff, the less it costs. You know, putting actual dollar amounts on there is hard, and this is from one organization. Your organization will be different, but it's a good exercise. So what you can do with 3.6 million is you can wait and get hacked and get that breach and be the Equifax, for example. Or you can try to be proactive, because with 3.6 million, you can actually do a lot of stuff. For example, in code, you can fix with 3.6 million, 3,600 issues, okay? So you can wait and fix one problem, and you still have to spend money then to fix all the other problems, or this is a rough estimate or a rough calculation of what you can do and how you can spend your money. To go a level deeper, if you say, well, I want to spend it on penetration testing, and you buy some penetration testing, the way you can calculate this, and again, I'm just giving suggestions here, you have to do that for your own organization, because every organization is different. What you can do over here is you buy 10 days of penetration testing, they find Y number of issues, the developer fixes the issues, which is Z numbers, and that's a pretty big number, so you divide it through the number of issues, and it's still a big number. Let's fill in the blanks. Let's say you spend 20K on the penetration testing and they come back with 10 issues and your developers have no time to fix it, which is essentially a waste of money, right? This happens all too often, right? This happens really all too often. We have the paper, you know, and that's it. No, so you have to fill it in right. There's a developer cost. There's a developer cost where he goes into the code, he has to find the problem find a solution to the problem, he has to fix it, go through to create that whole thing. Let's say $2,000 times 10 is 40K. So it's $4,000 an issue. Pretty big number, right? And fill out your own numbers to do this exercise internally. However, there's a side note here. These are real issues. You really have to fix them. If a penetration test comes back with SQL injection, it's very likely that attackers know about that problem too and will sometime in the future exploit you. So even though it's a high number, it's justified. If it's good stuff, of course. A SaaS solution, a SaaS solution, do the same exercise. I do not see quite often people doing that exercise, close to none. Jim Routh did it for Aetna, but other than that, I do not see people doing that within organizations. They just spend money, but they do not know what the outcome is of that. SaaS solution, X amount of dollars, issues found, Y, developer needs to fix it, Z, pretty big number. If you divide it through the number of issues, normally a static analysis solution comes back with a ton of issues. It looks better than penetration testing, but then you go to the theoretical side, right? From a theoretical perspective, it is vulnerable to SQL injection. Okay, so that's another side note. The numbers look better, but it's different. Training, what can you do for training? The effect on training, nobody measures the effect on training. There's very little organizations that know exactly what the impact of training is. The impact of training, they say we cannot measure that. You can measure that. You can measure that. You figure out how many issues they do not introduce into the code. Yes, it's hard to measure that, but it is possible. And if there are issues found by your penetration testing solution, by your static analysis solution, can they fix it? If they can, you have the training effect. So, let's see. Where am I? Okay, that's going to be good. What you need to do is measure. You have to start measure. You have to take these numbers internally. You have to look at how much I spent, what the issues are, how much it costs to fix, all these things. You can put it in there. You have to measure it, you have to calculate your ROI, you have to optimize your budget. What I've done throughout the last couple of years was I've a lot of numbers of what people spend on solutions and how many vulnerabilities they introduced and so on. And what I did this calculation, and it's different from Jim Routh's calculation, by the way, because if I would use Jim Routh's numbers, it would be very different, actually. It would be more than my $45. But over here, I looked into what I have in terms of numbers, and I figured out that every day a developer writes code, it costs an additional $45 to fix the problems that he introduces into the code, which I found very, very interesting. So every day that you pay for, first of all, the developer to write code, and at the same time, you have to pay another $45 to fix the stuff that he has written in the first place. Okay, so how can you bring that number down? Well, first of all, you can get rid of your developers. That's the easy fix, right? But nobody really wants to do that. Okay, so you really have to go through that exercise, and you can bring these numbers down. If you spend well, if you make sure that you know your numbers, you know exactly where you have to put more money in and less money in, so that you can optimize everything across what a developer sees, and you can help them out writing secure code. Okay, I think that's the end of my talk. Oh, okay, I thought it was 30 and 10, which is 40. No. So we're running a tournament. We're running a tournament today, and what you can do with that tournament is you can actually log in to the Secure Code Warrior portal, register. It's going to be, we're going to post it on social media, or you can take a picture, of course. That would be the easiest for you right now. So we should have opened it up at 10:30, which is now. Okay. If you go on there and you fill out the registry code and you add there in BeNeLux 2017, you can play a tournament. You can play against each other. It's not a hacking contest. No, it's not. We want to educate developers. We want to find problems in code, but also fix problems in code. All right. It's a learning exercise, so you don't have to be the top-notch expert to try it out. So please do not feel like, well, I'm not the best in that. No, that's not the idea. The idea is, hey, it's a learning experience. Go on there, try it out, see if you like it. And in the closing, we actually will give out prizes to the number 1, 2, and 3 in the evening. So if you want to play, if you want to learn about how to write secure code and how to fix issues in code, you can do that today. And with that, I would like to open it up for questions. So thank you very much. Yes.
So I have a question or a comment.
Absolutely.
So I really liked your talk. I think it was a great talk. But I think you're not going too far enough in your conclusions. So what you're saying is that, for example, training is important, or that code guidelines are important. But I think we should go further, and we should prevent vulnerabilities from being introduced. For example, you say we should make a coding guideline to only use parameterized SQL statements,
yes.
Right? But I think we should just prevent the insecure way, right?
Absolutely.
Why don't we remove, I don't know, string-based APIs from frameworks, so that that bugs cannot even be introduced? And I think on the training point, I don't think training scales, because you usually only need one developer that maybe was ill at the day of the training, or that didn't pay attention, or that just forgot about what was in the training. So instead of, I think trainings are important, but instead of trainings, we rather should harden stuff and make sure that developers can't introduce bugs, even if they want to.
So I absolutely agree on hardening stuff. I do not agree on training, of course, because for obvious reasons. But maybe we should talk and we should tell you what we do on a day-to-day basis with training and continuous training. But yes, absolutely. On your first point, if we can fix it in the framework, we should fix it in the framework and make sure it does not happen. The unfortunate thing is that we have a lot of legacy systems, and over there your approach will unfortunately not work. So you need something else. So you need to follow coding guidelines. And even if you fix it up, and then over there I call it more of a refactoring exercise, where you're going to then refactor your legacy code. And if you still can introduce some additional libraries, yes, you should do it, but you still need to refactor it, and you have to make sure that you refactor everything over there and that everything points to that one library. So you still need these coding guidelines that say, don't do it yourself. Crypto is a perfect example. Don't implement your own crypto. And if you have done it, well, if you did it, and you want to get rid of it and you want to install it with a new system, you have to make sure that nobody uses it anymore, because it's surprising how often it's so widespread within the organization, and this team is using it and that team is using it, and suddenly everybody is using it. So replacing it can be really, really tricky. But yes, I agree 100% with your statement, the first one. Yes.
I have the mic, so I have no. I have a comment and a question.
Okay.
The comment is, thank you for a presentation. I found it very too much black and white.
Yeah.
You see, you have red squares and green squares. Yeah. I think, as my colleague, I guess we should go farther, even lefter. And in my mind is that maybe you should, if you do kind of thread modeling and security requirements, you'll be able even to not have unsecure code from the beginning, because the developer won't write this code.
Yeah.
But anyway, this is a comment. The question is, from your experience, what do you think is the best ratio between all these boxes?
No, I see that my colors may be indeed a little bit more black and white. That was not that is not intentional. So I think you really have to spend across all these solutions, because again, you will not solve the world with training. You will not solve the world with penetration testing. You will not solve the world with one SaaS solution. No, well, to give you an example, when I was at Fortify, we ran a test and we were trying to figure out what the web inspect solution was finding versus what the static analysis solution was finding, and what the overlap was between the two. Well, it's different tools. They find different stuff. So that was a quite interesting exercise. That's why I'm saying you have to spend across across the SDLC. Let's put it that way. What's the best way to spend? It depends on your organization. It really depends on your organization. It depends on your culture. It depends on your technologies that you're using. It also depends on what you've already invested in security solutions. Some organizations have made bad choices, but then customized the solution in such a way that it is workable, and switching that out and another solution in is hard. So I cannot give you an answer to that question. That's why I'm giving you a lot of options here, how to do it within your own organization. But it has to be across everything. That's one thing that I'm sure of. And then you have to look at all the different things in your own organization to make sure you spend in an optimal way.
Hi.
Hi.
Thanks for a great presentation.
Very welcome.
My question, there are two questions, in fact. First, how did you arrive at 45? That's a pretty large number for a medium-sized company with around 200 or 300 developers, not to talk about large enterprises. Second part of the question is, have you tried of RASP solutions, and have they any impact in reducing this number?
Yes. So first of all, on Fortify, when I moved to the US and I joined Fortify as a researcher, the way I got in there was my PhD was around static analysis, and I was finding, so I was actually transforming low-level code from being totally clean to obfuscated code, and then trying to deobfuscate. And the way we did that was through binary rewriting, and for that we used static analysis. But the general concept was the same. You use static analysis, you do data flow analysis to find things in code. So the way I rolled into Fortify was really through my PhD, through my static analysis knowledge. Have I worked on RASP solution? Actually, I did. So initially, I started at Fortify doing more of the static analysis stuff. And in the end, I owned essentially all the runtime solutions, which contained a RASP solution, which is now called HP Defender or something like that. So yes, I've worked on RASP solutions. My experience with RASP solutions is you're holding the hot potato. So you're, throughout this entire cycle, you're going to put an agent in production, and you're holding the hot potato, because if it still comes through, that attack, and you say, I'm going to protect against SQL injection, I don't know what the legal consequences is, but for sure, I know you're holding the hot potato. That's one thing. last thing on RASP solutions, it's really, really hard to get that in production. It's really, really hard to convince the people to put an additional piece of software in your production machines that's going to do security things. So if you can get there, good. But from my experience, a lot of organizations see that more as putting additional software, additional risk in production than actually preventing risk.
Yeah, thanks very much for that interesting talk. I quickly want to emphasize that point was that we really need to help the developers in developing securely. My experience is actually that in the last years, it's more the situation that they want to develop securely. It's a long time ago that I had discussions about not fixing a bug. Maybe I'm belonging to those few people that actually did that money calculations within the company I was working for.
Good. I'm very interested.
Gives an interesting insight. I can really recommend to do that. But if you do that, don't only look at the money of the tools that you are buying. Look also at your internal costs and your internal processes.
Absolutely.
I wouldn't be surprised if you learn that by optimizing your internal processes, you can save much, much more than by reducing licensing costs for an external tool or an external security audit.
Absolutely. No, and I think that, so this was a little bit too a slimmed down version of my calculation, of course. But yes, what I tried to slip in there was, yes, you have that developer cost, but in that developer cost is essentially all the costs that you need to fix a problem in code. So yes, couldn't agree more.
So I'm an academic, so I'm trying to figure out if my view of the world is a realistic one.
Okay.
So if you look at the books of Gary McGraw, he writes that 50% of the codes of the errors are actually code level bugs, but the other half are architectural flaws.
Exactly.
And so if I'm correct, you focus mostly on the bugs.
Absolutely. Yes.
But where are the risk analysis and the flaw analysis stuff then?
No, absolutely. No, you're right. So there's bugs and there's flaws. I totally focus on the bugs because some of these solutions, like static analysis solutions, also claim to find flaws, but that's not what they're made for. They're really made for finding bugs. So this kind of system, the stuff that I outlined today, works really, really well for finding bugs in the code because these are the developer mistakes. If you think about flaws, yeah, you really have to do threat modeling, architectural risk analysis, and that's more of a manual process. I'm not really aware of any good tools that can help you in doing a deep analysis. And there's definitely tools that can help you with architectural risk analysis and threat modeling. And you can put some data in there so you have a good idea of what's going on and what you need to do from a threat modeling perspective and finding the flaws. But it's different. It's still a manual process. You have to feed that data into that model, and that model will then help you finding the flaws in your system. So it is very, very different. So I do not have a good answer to you what kind of I'm not the expert in that kind of field. I've done some of that during my time at Fortify doing threat modeling, but I'm not the expert in that kind of field. But it's a different thing. It's also not a developer-focused thing. Developer is more taking on what the architect is saying. For finding flaws, it's more an architectural problem where you need your design people to get into one room, have a whiteboard, draw some pictures, and make sure that the flaws are not there. Yes, yes, that's right. This is 100% a talk about finding the bugs in the code.
Okay, time for one more question, quick one. Everybody is urgent for coffee.
All right.
Thanks again for Matias Madou.
Very welcome.